channel Bal Vigyan Bharti. Here we are continuing on vector addition problem solving session, and in which we have reached 24. Now further we will move on to 25. The 25 problem says the sum of two forces, the sum of two forces acting at a point is 16 Newton. If the resultant force is 8 Newton and its direction is perpendicular to the minimum force, then what are the forces? Okay, I have to define find the forces. So one first equation is that the sum of the two forces, that means if its force is A and B, the sum of the two forces means that is equal to 16. Okay, and the sum of the two forces need not to say it as, that means sum of the two forces, if it is there acting in the same direction, the maximum is 16. That is the implication of this part. In the if the resultant force is 8 Newton, means the resultant of A plus B, if I take the resultant, that is equal to 8 Newton. This is the second one. Okay, sum of the forces means if I take the value of this individually, that means if two forces, say any forces, which cumulatively if I take the magnitude, it will be 16, and the resultant, that means if I add the vector with the parallelogram law, that will give this one. So that means if two vectors acting in any direction with the theta angle AB, so resultant of AB is this, but individually if I add the magnitude of AB, that is 16. So basically it is A plus B, you can say. Here this is nothing but A square plus B square plus 2AB cos of theta, the theta angle, that is equal to R. This is signifying this. Now another thing, what are the angle in between? If I say that two vectors are acting A and B and the resultant this, so this angle alpha, that is tan alpha, is equal to, now if I draw it correctly, it says the resultant is this way, minimum vector, let's say A is this way, that makes 90 degree perpendicular to the minimum, and the other vector we are assuming this way. So if I want to calculate this, if I calculate this 90 degree, so and this is the theta that we have considered here, this is theta, so tan alpha is equal to what? B sine of theta divided by A plus B cos of theta. That is the formula. Now the tan alpha is equal to tan 90 as per the condition given. So tan 90 is equal to infinite. To fraction be infinite, its denominator should be 0, is equal to 0. So from here cos theta you can say a by b, that we can put it here. So if I square up the both side, it will be a square plus b square plus 2ab, and cos theta is equal to minus a by b. Okay, this is equal to r square means 8 square means 64. So this will be cancelled out. Ultimately we'll get b square minus a square from this. So this will give you b square minus a square is equal to 64. So we are talking about the magnitude. Basically this is the magnitude. Now b plus a is given as, so magnitude of b plus a and b minus a, that is equal to 64. So b plus a is equal to 16, so b minus a is equal to 4. So if you solve these two, b plus a or b minus a, will get b is equal to what, 10, and a is equal to here 6. So this will be answer. What is the two vectors? So these are the two vectors. It will be in Newton. So to put the unit of that. So this is the solution. Moving to problem number 26. Problem number 26. He said what vector must be added to the two vectors. The vectors are given with I minus 2j plus 2k and 2i plus j minus k, so that the resultant may be a unit vector along x axis. Okay, so if I take this statement, the unit vector towards x axis is what? It is I. So I have to add these two and another vector. Let's say the vector is a. So I am adding this plus this one plus 2i plus j minus k and plus another vector I am adding. I am getting resultant I. So what is a? Bringing all this side, I, this is I, this is 2i, so 3i minus 3i this side, minus 2j plus j minus j, that side will be j, k is 2k minus k, so k, so that side will be k. So ultimately it is minus 2i plus j minus k will be answer. Okay, so this will be the another vector which has to be represented by this to be added to these vectors to get the unit vectors towards x-axis. Okay, moving to the problem number 27. What is the angle between P vector and resultant P plus Q and P minus Q? So I have to find the angle between P and the resultant of these two, and resultant of these two. Now if I assume a vector, it is P, another vector Q, okay, so they are making an angle theta with that. Now one P plus Q is coming, so this will be something like that. So resultant will be, let's say this is R1, which is between P and Q. So this R1 has to be P plus Q then. Okay, now if I extend Q on the other side, because this is P minus Q, so this will be minus Q. So the other parallelogram, that will be like that. Okay, so I will take this will be R2. And now what is R2? R2 is P minus Q. Okay, now we have to find the angle between the resultant of these two. Further, if I take this by symmetric, we can say that this is, but how is that coming? So we have to find the angle between the resultant. If this is the resultant R, let's say, so whether it is linear or collinear with P or other, that will come down. So first the resultant is, resultant vector, you can say P plus Q plus P minus Q will be the resultant. If a vector summation is we are doing, so ultimately this will be cancelled out, we'll get 2P as a resultant of these two vectors. Now this is what P is a vector multiplied to the scalar. This will not change the vector, only the magnitude will change. So that if P is with the direction this, then 2P also follow the same direction by the double of the magnitude. So we can conclude that R, that means 2P is representing the R. So R and P are in same direction, isn't it? Because there is no other component, any component of Q is coming, only the P. So if it is only multiplied with the scalar, so that means the P and 2P will be in the same direction. So the resultant R of what? This and this with the P making 0 degree in the collinear. So the answer will be 0 degree. That means the P and the result R are collinear, same direction, or you can say collinear. Okay, collinear vectors. So moving to the next 28. The resultant of two vectors P and Q is R. The resultant of two vector P and Q are is R. Okay, the resultant. If Q is doubled, then the new resultant is perpendicular to P. Then find R. Now the first condition is that the two vectors P and Q, if we say that this P, this is Q, okay, making a resultant R. So we have to complete the parallelogram. So this is the R. Okay, if Q is doubled, now Q is doubled, so let me draw it somewhat below, so I have to get a space. So this is Q, this is I can see. So I will complete this parallelogram. This will be R. This is Q. Now Q is doubled. I am increasing this by double. So this will be, the new one will be 2Q. Okay. Now if I add this, the new result will be this one. This is R1. Then the new resultant is perpendicular to P. Now this angle, as if it is initial alpha, this new angle alpha 1, if I say this angle say alpha 1, that alpha is 90 degree. It is saying 90 degree. So that means it is making perpendicular then. So in that case, the tan alpha 1 is, if I follow the same thing, this case, this is will be 2Q sine of the, if earlier angle between the vector is theta, so this case also this will be theta, only the it is multiplied doubled, so it will multiply the scalar, so direction will not change, so theta will be theta, so this case will be theta, so it is P plus 2Q cos theta, and earlier it is alpha, if I say this is sin theta. Just for comparison I am writing, so that you should not be confused. So this will be the new one, but new alpha 1 is equal to 90, so that means your denominator for this case will be 0. So P plus 2Q cos of theta is equal to 0. So from here cos theta is equal to how much? Minus P by 2Q. Okay, now the resultant, the R. The R is the first case. First case R was this one, which is under root of P square plus Q square plus 2PQ cos theta. Now cos theta is this one. If I calculate it, is Q square plus 2PQ, and cos theta is equal to minus P by 2Q. So 2Q will be cancelled out. This will minus P square. So ultimately this will be P square, so P square will be cancelled out. Ultimately this will become P square plus Q square minus P square. So ultimately this will be Q. So resultant, earlier it is equal to the Q, and this is the R, so this is equal to the vector Q. Okay, this I found. So this is the requirement. Then find R. So R is equal to Q. Okay. So moving to the problem number 29. Given A plus B is equal to C, and that C is perpendicular to A. Okay, fine. Further, magnitude of A is equal to magnitude of C, then what is the angle between, is the angle between A vector and B vector. So let me try to draw the thing. A plus B is equal to C, that means A may be, I suppose this one, and C is the resultant. C is making 90 degree with A, this is C, and B will be somewhere here, B. So ultimately if I increase it, I will complete the parallelogram, try to merge it here. So this will be something like that. Further, A is equal to C. A and C are magnitude cells. Then what is the angle between A and B? So this you have to find theta. Okay. So formula wise, C square is equal to A square B square plus 2AB cos of theta. Now C is equal to A, if I say, so I can write A square is equal to A square plus 2 B square plus 2AB cos of theta. so this will be cancelled out. Ultimately b also cancelled out, so b plus 2a cos theta is equal to 0. So a is equal to cos theta is equal to minus b by 2a. This will be the first one. And if I take the angle of tan of 90, that also I think it will give the same thing, b sine of theta by a plus b cos of theta. So from there, this has to be cos 90 is equal to infinite, this will be 0. So from here we can get cos theta is equal to minus a by b. So if this cos theta has to be same, this has to be equal to this one. So we can get this, both are minus. So b by 2a is equal to minus a by b. So b square, this will be all cancelled out because this is minus. Ultimately we have to start with this, so minus minus will be cancelled out. B square is equal to 2a square. So now it would give you if I take a by b, this will nothing but 1 by root 2. So cos theta is equal to minus 1 by root 2 because a by b I am getting here. So minus 1 by root 2. What is the value of cos 1 by root 2? That is equal to cos theta is equal to minus cos of 45 degree. 1 by root 2 is 45 degree. So minus, how it will change? So cos of 90 plus 45 gives you the minus, because 90 will change to sine. This will be 180 minus 45. Then that will be a, because cos 180 will be remain as cos, and as because in second coordinate it will be minus will come. So cos, so this will nothing but cos of 135 degree. So your theta is 135 degree. So this is the value. Okay, so this is for now. In the next video I'll move on to the problem number 30 onwards. Okay, thank you.